Ladies of calculus, good morning, and welcome again to room 15 where
Learning
never ends. But learning was delayed today. Why was learning delayed?
The board was messed up and you made hot chocolate.
Yeah, so I had a board that was upside down because I mistakenly laid this pad on my remote and somehow turned the image upside down, and then hot chocolate on a cold, it's a wintry day out there, isn't it?
Yes.
This is a hot,
Here, let's see how cold.
this is a hot chocolate day, isn't it?
Can I see what the temp is, Larry's?
Yeah, you can. Go ahead and take a look at it. How much? What is it?
29.
29. For this time of day, that's really cold.
Like,
17.
It feels like the less.
17 degrees.
Yeah, so very good. And then what happens is, I really have one thing that I remembered to do today, because Kenzie reminded me yesterday. She reminded me of the chicken and the egg shirt.
We should all wear it one day.
Which is what we have now. You did wear it one day when we had the pictures, right?
Yeah.
Yeah, so that was
I wore a
good.
separate day.
But this one here, and I'm glad that Kenzie remembered it yesterday in Cooper, because this is pretty relevant for what we're doing now, isn't it?
Yeah.
So we're taking this, let me show you.
We talked about your shirt on the phone.
Oh, you did? Okay, very cool. So there it is. The derivative of chicken is egg, and the integral of egg dx is chicken. So it's an inverse sort of relationship to each other, right? And so that's what we're doing. So we've progressed from differential calculus mostly to what we call integral calculus. And it's the relationship between the two that is what we're trying to accomplish, and where they are in the hierarchy of f of x, f prime of x, f double prime of x. And you can go up and down between them. And that's what we're doing. That's exactly what we're doing. So, did anybody besides Karina try number 15? So go take a stab at number 15, because that's what Karina specifically asked me. She came here before school and asked me about it.
Inverted, I would like backwards.
So you're working on number 15? Emily looks like she's working on 15.
Like inverted?
Are they like-
Inward.
Like if your face was inverted, it'd be inverted.
Can I explain my knees?
Yeah, go to that, but I need you to work 15 also.
Oh,
Explain
so
your
you're
knees.
like, so you walk like a brat style.
Okay.
Because their knees
Like
touch. Their knees
And
touch.
mine looks like it's like
It's
Those
Okay.
boots don't look very comfortable
I
though.
like the jeans.
They're pretty though.
They are very pretty.
Pretty strawberries.
And it makes you taller too, right?
Yeah, 4 extra inches.
Yeah. They are pretty, I can mention that.
I can be sure that we can try one too.
They're 4 inches, not 12.
So how are you coming on number 15? Emily, you still okay on 15? You finish it?
I'll figure it out right, but I.
Okay, all right. So what about you, Katie? You haven't finished? This is an example of one of these calculus problems that is made to make to look more difficult than it really is.
Yeah, I feel like once you work it out, it'll be easier.
And a lot of them are. That's the thing about those, like the AP calculus tests. They take the problems, the basic concepts, and just dress them up to make them more intimidating.
Yeah.
And then also they echelon other steps in there to make it.
You sing videos, right?
Yes.
Can we have one day where we just like go back in time to like 4th grade and learn some 4th grade math?
Oh, yeah.
Yeah, if you have a list of things to go over, yeah. If there are a list of things to go over and you feel you're deficient in, we need to go over this. So if you can provide me with some specificity about what particular things to go over. Because the 4th grade math, do we still need it at this level? Yeah, we do, right? It always is with us. And that's why we're going over fractions a lot, and we're
We
going
should
over
do times
factoring.
multiplication
My brother's
test.
in 8th grade, but he
Time multiplication test, I don't know if we can do that. I don't think I can do that, but
I will murder y'all.
other things.
In cursive? L and M. No, not even in cursive.
What?
What, right now, I distract Mr. G. Bryce distracts him. Hauser, and he told her that she was wrong for how she wrote her A's or something. And so now they're going through the whole alphabet, learning how to write them.
Miss Hauser's doing that?
5th grade,
8.
8, how old is it?
Oh.
I was thinking about Miss Wallace, 5th grade. The only cursive I know.
Okay, you ready to go over this one?
Yes.
Let's go over this one. Okay. What I'm going to do with this one is separate this up into 2 separate integrals. So I'm going to separate this up into x to the pi dx plus, what I'm going to do is I'm going to put square root of pi integral dx. And what is this going to be? What do we do at this pi?
Put it front.
Okay, we make this pi what? Plus 1. And we divide by
5 plus 1.
pi plus 1.
Y'all are so good.
And then this one over here is going to be plus square root of pi
X.
x.
Plus C.
And never forget to add the c. That's from a calculus song, right? So that's it.
See, yeah, that was pretty easy. The only thing is I didn't know about the pi, but I get it now. Adding the one.
Yeah. Uh-huh.
I'm trying to find my pin.
So again, a good example of a problem that's made to look more way difficult than it really is. But I'm glad they did that. This guy, Mr. Schwartz, who invented this thing, and you see his name at the bottom of the page, Stu Schwartz, you see his name?
Yep.
Yeah, he's the one who came up with this. And basically, it's a lot of exercises he came up with to help us. So thank you, Mr. Schwartz. We appreciate you.
We love you.
And I think my mentors paid him for the material that we're using. So I'm gonna have to ask her when I see this. Okay, now here's one where it says, in taking integrals you may have to be clever, and there are certain sets of rules. And if an integration problem doesn't fit one of these rules, you may have to change the expression so that it does. And he calls this a bag of tricks. So here, and what I'm going to do is, I don't want to do the whole thing, but this trick 1 is multiply out then integrate, right? So if we go ahead and multiply this out and integrate, that's going to be 4x squared, and this is going to be minus 12x plus 9, and dx all that, right? Okay, so that's the trick. So once we get to this level, that's pretty easy, right? Okay. Now let's talk about this next one. Split. So split. So we just integrate from here, so this is going to be really easy. Let's just go ahead and finish this off, since we can do it. So that's going to be 4x to the third divided by 3 minus 12 x to the squared divided by 2 plus 9 x plus c. And if we want to simplify this thing, we can change that to 6, right? We can change that to 6. All right? Pretty simple? Okay. Now the next technique, and we've already done this just a little bit. Now I'm erasing this just to make room. So the other thing we have here is split into individual fractions, then integrate. So for 17, what we would have is the integral of x squared over x to the fourth plus 3x over x to the fourth plus 1 over x to the fourth, and then we can dx all that, right? So it's dx, all that. And so we can, so is everybody okay with this step here? Right? Everything's good? So here, what we're going to have with this is going to be, if we divide out, what are we going to get here? X squared divided by x to the fourth, what is that going to be?
Now you subtract the exponent, right?
Yeah, so subtract, you can subtract the exponent, so it's going to be x to the negative 2 power. And I'm just going to go ahead and make this a dx like this, and then handle this one.
That one's gonna be -4.
So this one here is going to be plus 3, and we'll say x to the negative 3 dx. And this one's going to, last one's going to be plus x to the negative 4 dx. Now Kelly was joking a little bit earlier today, and maybe she wasn't joking about going back to 4th grade. You weren't joking, were you? She wasn't joking about it. But in truth, what you do in calculus is you do reach back and to all the math you've ever known in your life pretty much, and bring it and use it at some point in time here in this class. Is that right? I think so. To me it looks like that. So now we go ahead and take, this is going to be x to the negative 1 divided by negative 1 plus 3 x to the negative 2 divided by negative 2 plus x to the negative 3 divided by negative 3 plus c. That's supposed to be negative 3. And then just kind of simplifying and kind of cleaning up on the right. So that's going to be equal to negative 1 over x minus 3 over x squared. Is that right? Minus 1 over 3x cubed plus c. Did I make any mistakes on that? Which 3? This one? It's this 3 right here.
Why doesn't the 2 have?
Oh, hang on a second. Hang on a second. You're right. Hang on a second. No, it's divided by 3, so it's going to be negative 1/3 over it. So that's right. Don't you think?
So then what is that, the one
The
be
2?
two?
The negative 2?
The middle one, it should be
2x squared?
Oh, okay. I see what you're saying here. 3 over 2x squared. That's my mistake. So that was your mistake you're talking about, right? Or my mistake you're talking about. That's why I asked you if I was making a mistake. I was. Thank you for catching that. Okay? Now does that make sense? No? Okay. Which step in this whole process here, which line 1, line 2, or line 3 are the incomprehensible steps? All 3 of them? Line 2? Okay, let's look at line 2 then. Because line 1 shouldn't be any big deal, right? You're just taking these things and writing them up as individual. So this line 2, you have a question about this one? So this is going to be x to the negative 2 power, right? Subtract. So it's the principle of x to the a over x to the b equals x to the a minus b. And so here we have x to the 2 minus 4. Here we have 3, x to the 1 minus 3. And here we have, this one here is just going to be x to the 0 over x to the 4th is x to the negative 4th. So we have that, okay? And then these ones here, this step right here is straight up using the integration power rule. Bump up, divide. Bump up to the negative 1 power, divide by negative 1. Bump up to x to the negative 2 power, divide by negative 2. X to the negative 3 power, bump up, or x to the negative 4 power, bump up to negative 3 and divide by negative 3. And then this last line here is all just simplification of that. That's all that is. Okay. Okay, now this next thing is the differentiation integration thing, and we're going to go into this in more detail later. But basically for this one, the things you need to remember is this one, that when you integrate or when you differentiate, you go in this direction, so that the differentiation of sine is cosine, differentiation of cosine is negative sine, differentiation of negative sine is negative cosine, and then integration is the opposite direction. So integration is going to be like this. And anytime I do these things, especially integrate, you know what I do?
Write that down.
I just make a quick sketch of this little thing, especially if I'm a little fuzzy on it, just to keep remembering. It's just like when I do it's just like I do this. When I do this F prime, F double prime thing, when I write that plus minus, you know what I'm talking about, right? So I use these little remembrance tools. Excuse me, yeah, it's going to be same thing, okay? I just write these little things when I know that my memory could be a little fuzzy on the thing. Hey, just write down the tool, use it. And I'm telling you that as a person who's been teaching calculus for now 11 years. If this helps me after 11 years to do this, do you think this might be helpful to you?
Yeah.
Yeah, so just keep those in mind, because you have this little toolkit you can go to. And once you do this, you can sort of be on auto, you can go do this automatically, and you can pay attention to other details that will be easier to miss if you're trying to concentrate too much to do this stuff. So what it is, you're sort of training yourself to be a calculus machine. Does anybody want to be a calculus machine? No? You don't? Okay. Well, all right. I understand that. I understand that.
I mean, it'd be nice, because then it'd be easy.
Yeah, that's right. What you're trying to do is you're trying to make it, I do these little things, I suggest them to sort of make things easier. Because if you make some things easier, then it becomes easier to pay attention to the harder stuff. Because you're not all wrapped up in the mechanical stuff. So anyway, solve the differential equation. We have, it's hard to see here, but it says this is f prime of x equals 3x minus 1, then f of 2 equals 3. Solve the differential equation. Well, how are we going to do this? Okay, I'll show you how to do this. The thing I suggest when you have these situations here is just rewrite this f prime of x as what?
What?
And then we'll say dy dx. So you change f prime of x to dy dx, which is synonymous to f prime of x. And you set that equal to 3x minus 1. And so what's the next step? Anybody remember what that is? We did one like this before.
Alright.
Do,
3. Next is 3.
Okay, let's go ahead and cross multiply. So dy equals, I'm going to put here 3x minus 1 dx. Okay, what's the next thing? What's the next thing? Yeah, we're going to come to that in a minute. We're going to come to that, but before that, so Emma's thinking the right way. Before that, we're going to do this. Doot, doot, right?
Oh, yeah.
So that's what I meant. That's what I was waiting for somebody to say. But Emma was already,
Why did you put those on?
no, Emma was already a step ahead of me though, right? Right? So Emma was a step ahead of me. Thank you for being a step ahead of me, Emma. Okay. So what do we have here, Emma? It's going to be 3x squared over 2 minus
1x.
x plus c. Okay, what kind of solution do we call this?
General.
General solution. So I'm going to abbreviate that, call it a GS. Call it a GS. And what do we need to do? What do we need to do next?
Plug in the point.
Plug in. So 3 goes here, right? So 3 equals 3 over 2. And we have, that's going to be 2, right? 2 squared. 2 squared minus 2 plus c. So that's going to be, what's it going to be? 3 equals, that's going to be 12 over 2, right? So 6 minus 2, is that right? Plus c. I'm just going to work to the right here. So we have 4, so 3 equals 4 plus c, so c is equal to? So c is equal to negative 1. And what do we do with this negative 1? So we have, so we go over here and it becomes y equals, and you can make this f of x too, right? I'm just going to call it y equals 3 halves x squared minus x, and what goes here? Minus 1. So this is called your particular solution. I'll call it PS. Okay? What I want you to do is take a stab at number 19, which is a similar type of problem, right? You can do number 19?
We can try.
We can try. That's what I asked you to do today. Good job. How was the hot chocolate back there? Was it okay?
Yeah, it's good.
Okay, good.
Still hot. So
Did it keep you warm?
I haven't drank it yet. It's still hot. I took a sip though.
Oh, really?
Yeah.
Wow, okay.
It's really hot.
You put it
Okay.
in for a long time.
How long did you cook it for?
You know something? I meant to cook it for 1.5 minutes. I probably did for 2 minutes. That's probably what happened. I just lost track of time a little bit. I don't know about you, but I'm glad we have a Dollar General store in this little town.
Yeah.
It's just very convenient, like. Because if we didn't have Dollar General in this town, where would you have to go all the time?
Oh,
You'd have to go to Kaufman all the time.
Or on the other side. You know, like the grocery side. The grocery side of the store? This side around the back. Yeah.
There were all the.
No, it's just saying on the right.
Yeah, but that's
Off
also
of
good.
the-
I was like, if you were coming out of the store.
Just on the other side is just the tree. The other side, this side's not, here, I'm looking at the store. This is an open field, this is the tree.
This one's like, that's like, basically.
Okay, you ready to go over 19 yet?
yeah.
Yes?
I got to the end.
You got to the end? What about everybody else?
Yeah, I'm getting there. I just have to plug in the
Yep.
number.
You're close, Emma, you're close? What about Elizabeth? You have number 19 done? Yeah? Looks like she's working on it. You have number 19 done, Karina? Okay. Let me give another half minute and we'll go over this. Okay, I'm gonna erase this to make room, all right?
All right.
Okay. So here we have, I'm gonna rewrite this dy dx equals x squared minus 2x plus 2. And then dy is equal to all this. And one thing you'll see a lot in calculus, you'll see this a lot. But if you're doing that, I don't like this notation because I want to make sure that you communicate that means it's dx times all these things. And Karina was asking me this morning, what is the meaning of dx? Well, dx is when you integrate the area under a curve, which is what integration is. When you have a curve like this, dx means a rectangle, means the width of this rectangle is dx. And in calculus, what you're doing is you're making this width of this rectangle infinitesimally small to get the area. So what you have is this width of these rectangles times the height, which creates an area. So that's what you're doing. That's what that dx does. Does that make a little bit of sense? Yeah, it should. If you think about it, it does. But that is really what integral calculus is. And so here, if we take the integral of both sides of this, we have y is equal to, we have the integral of x squared dx minus 2 integral of x dx plus 2 dx. And then we have, it's going to be y is equal to x to the 3 divided by 3 minus 2x squared divided by 2 plus 2x plus c. And the negative 2 over 2 will cancel out to be 1, right? So I'm just erasing that because that cancels out, okay? So now that we have our general solution, to find a particular solution, we take negative 1 is equal to, we have 3 cubed over 3 minus 3 squared plus 2 times 3 plus c. And so for here we have 20, that's going to be 9, negative 1 equals 9, minus 9, plus 6, plus c. So they will cancel. So c is equal to negative 7, is that right? And so here we have, that goes whoop. And so we have, I'm just going to go to the left here. So we have, it's going to be f of x equals x cubed over 3 minus x squared plus 2x minus 7. So this is our,
Yeah, woo!
you got it right?
Got it.
Yeah.
So who else got it? So a lot of you got this right? Okay, good. So at least 3. Okay, good. What I want to do with the remainder of class is I want to give you a homework assignment to start working on. And I'm going to give you quite a bit of time to work on it. I want to give you quite a bit of time to start working on it. So this is that whole thing, okay?
Is it problems like this?
Yeah, it'll be problems like this. Yeah, so some will be, it'd be like anything, right? Some will be easier than others. And so, it's from your packet, and I'm putting it on a separate sheet, so you can just take these home with you,
I
right?
feel like we haven't done a picture like that in a while, or like.
Yeah, okay. Another thing is I need to get grades in the grade book too, especially by tomorrow. Why do I need to have them by tomorrow?
Our grades do?
Progress report day.
What do you mean? This is my second day back. Yeah.
But it's supposed to be after January 4th, right? But what I'll do is I'll make up a homework grade. I'll give you a good grade on this one, as in, what's a good grade?
100.
I'll have one in the grade book, and then I'll have this graded too. This one is not going to be due until Monday. Okay? Now I want you to take some time. I'll tell you which ones I want you to do. I don't want you to do all of them necessarily, because you have, how many of there? You have 18 on there?
Yeah.
Yeah, so I'll show you which ones I want you to do and how I'm going to help you with those.
Come on, Lord.
Okay, so here we are, right?
Yeah.
So what I'm going to do, what I want you to do is, these things are in columns, right? 1, 4, 7, and so forth. What I want you to do is these two columns here, so I want you to do 1, 2, and don't do 3. Do
Only do the first two columns.
the first two columns, so you'll do 12. Okay, and my intention for helping with this is I intend to make a video of the entire right column.
Okay,
That'll have 6 problems. I'll call it Indefinite Integral Homework Help.
got it.
That'll be the title, and I'll make it after school today, and I'll send it out via Remind later tonight sometime.
Is this due tomorrow?
No, on Monday.
Okay.
Monday. In fact, I'm glad you asked that question, because I don't really necessarily want you to do all this at one sitting. I want you to say, okay, let's do 1 and 2, work on it, and because I want you to get some bite-sized pieces to kind of take some time to review, do some today, some tomorrow. What is that going to do by taking a little time working
Keep your
through it?
memory fresh.
Keep the memory fresh. If you can do, I heard somebody say 10, 24/7. So if you can do something 10 minutes later, that helps to mentally. If you do something 24 hours later, that's good, and 7 days later. So I want you to do it that way,
Got it.
and then I'll have it for you, and you guys will be good. But I want you to return it. I want you to turn it in first thing Monday morning.